Christopher Allen will be taking us through this session. Today he will introduce himself and introduce the session, and then go on. This, when the session is ongoing, we want us to mute our mics and listen. And after the presentation, we will have time to ask questions, and I'm sure you'll be willing and ready to answer them. Thank you. Christopher, you can please start the session.
Okay. Hello, everybody. My name is Christopher Allen. I live in New York City, actually. And today I'm going to be talking about reality capture. So I've titled my presentation, As Built, As If. It's just a little bit of play on the process of, always trying to deal with as-built in the construction world and how it rarely measures up to what you find in the field. So today I'm going to be talking about reality capture, how it relates to BIM, and I guess best practices and potentially the future of reality capture and why it is important to our field. So a little bit about myself. I went to school out here in the US in Atlanta, Georgia, a school called Georgia Tech. Studied architecture, got into the construction field. I worked for architects, engineers, subcontractors, all in their BIM department, mainly doing Revit modeling. Ended up in doing automation, running a BIM team. Eventually got into the construction side of the field, where I noticed, there was a big need for technology to sort of take a place there. And got into essentially reality capture services, figured out the benefits of it, how it saves time and money for the industry. And I've slowly been trying to bring that process into other companies and businesses so that they can see the value and make the processes more efficient for themselves. So it's a path that I never at the beginning of my journey saw myself taking, but here I am today. So hopefully you guys, can learn something, share my enthusiasm, or, at least come out of here with a little bit more knowledge of the process so that you can apply it, continue to talk, or what have you. So I guess the problem, the current issue with, I guess, the reality capture process or a site survey in general is that you don't get accurate information. And as with actual construction, a good foundation is always necessary for successful completion of a project. So it's the same with actual construction, and it also applies with the design side of things. So the better framework you have to start with, the better the experience throughout the whole process. Obviously, the current process for most utilizes hand measuring techniques. You're talking about measuring tape, laser measuring, and that leaves a lot of room for inaccuracies, especially when you deal with curved walls, especially when multiple trades have their own site surveyors that are to get dimensions and information, that is not consistent with each other. Most as-built drawings only reflect design intent and not final design of a building project. What I mean by that is most of the times, if you are given a set of drawings, they don't accurately reflect what is built. They reflect what is supposed to be built. But after completion, very rarely are people going back to update their drawings based on what was actually done in the field. Or after construction, there may be slight improvements that go on between the completion of the project initially and when you go in to do your own tenant improvement. So that lack of record keeping, if you just take those drawings and apply it to your new design, you may be missing out on a lot of information. And then there's also, historical buildings that lack a set of drawings, period. Some drawings are owned by the architects and engineers, and they might not want to provide it to you for the purpose of your project because they're not involved. Very selfish practice, but I've seen it time and time again. So ultimately, to sort of, eradicate this problem, reality capture has become a tool to easily gather this information without having to deal with all of the guesswork and issues of sort of trying to figure out whether the information that you are given, if you're given anything, is accurate. So my mission is obviously with this presentation is to give you guys the information so that you can provide the highest quality and most accurate as-built as a basis for design and record keeping, or, during construction, as-built can be used for progress and coordination of trades. So, I mean, regardless of where in the process you are using reality capture, it's always going to give you the highest quality and most accurate information. And that's obviously what you always want. It reduces the time it takes to gather information. Obviously, using a laser scanner, something that is utilizing electronics and technology and automation, it usually outperforms a human being by leaps and bounds most of the time. And, with reality capture, it's no different. Reduce RFIs and change orders in the field. Obviously, if you have the most accurate information that you can, by the time you get to construction, there should be no sort of surprises on site. Therefore, if there are less surprises, there should be less issues that come up, less questions, less change orders. And obviously, last minute change orders often cost a lot of money. So the more that you can reduce those, the more money that the project is making or that you're saving in the long run. Eliminate guessing in terms of what is on site is the next point. And obviously that just kind of ties into everything else. If you're using the laser scanner or another reality capture device, you're getting what is there, what is actually there. So you're not using existing drawings and just assuming that they're right, or, using your dimensions versus someone else's dimensions and just, I don't know, preferring yours to someone else's and saying that mine is probably right because I did it. You use this, you have one single source of truth, and, there's no guesswork involved. Reduce unexpected construction costs to minimize actual construction costs. Like I already talked about that, it kind of ties into the RFI and change order process. If you have more accurate information, there's less changes, there's less surprises, and then there's less unexpected costs. And then finally, integrate reality capture into all applicable pre-construction processes. It is my goal to prove to you that reality capture is the best way for gathering as-built information. And then with that information, obviously, my hope is that you buy into the process and then start to integrate that into the pre-construction process where it is mainly used, but obviously during construction and post-construction as well, it is also a useful tool. And then this overview is just, I guess, a list of the different things that I'm going to talk about today. I really don't need to go through all of them. We'll just go through the categories as I start discussing them. So I guess first, before you talk about reality capture, you have to talk about what BIM is, building information modeling. I'm sure we're all familiar if we're here in this presentation today. So I'm not going to dive into that for too long, but obviously BIM stands for Building Information Modeling. It's the process of creating a digital representation of a potential physical entity. Obviously, we're in the construction industry, so that usually involves a building, furniture, fixtures, and equipment. But obviously, BIM can apply to any other industry when creating machinery, prototyping, et cetera, et cetera. But that's not really in our wheelhouse for today. But BIM is the reason we're all here today, and specifically, we're going to get into reality capture. And then here's a slide just showing all of the different, I guess, uses of BIM. And we all pretty much know these, so I will just skip over this slide, but I just thought it was very informative. Next, what are as-built? So as-built are a revised set of drawings used to accurately show existing conditions for a specific project. Now, usually when people speak of as-built, they're referring to a set of drawings used for the DB phase. So what are the existing drawings? Existing drawings and as-built are usually used synonymously. And it is true, but it is not completely true. As-built are just showing the current representation of the site. So before you start a project in pre-construction, yes, it is the existing conditions. During construction, it could be progress drawings. After construction, you know, as-built could be referred to as a record set or facilities management drawing, or there's a few other terms, but essentially as-built are just drawings that are showing, you know, what currently exists on the site. And obviously that fluctuates given the site conditions on any given day. And then here is just an example of some as-built that I had to do in the past, just going on site, hand marking before I started getting into reality capture. Obviously a very messy process. You have to write it all down, then you have to translate it digitally, and then you have to go and do all of your 3D modeling afterwards. And you know, that's if you're given a good set of plan drawings to start with from the beginning. Oftentimes the layout is different, and then you have to end up sketching your own, which is a whole other can of worms. Now, how are as-built relevant to the BIM process? As-built in pre-construction are used as a basis for the design development and eventually the construction documentation phase of construction, as I said before. As-built during construction are used to assist in the coordination of all trades as field teams complete phases of construction. So VDC coordination is a big part of the BIM process now, the construction process. So as-built models, you know, they're always a current working model. If BIM is heavily used in the construction process, the current working model would be the same as an as-built model, which is then always used for coordination of architecture, structural, and any sort of MEP. As-built in post-construction are used for record-keeping purposes. These drawings are held as a resource for future construction. These drawings are used in other applications for facilities management, virtual building maps, marketing, and even video games. So obviously, after construction is completed, most owners will ask for a model that represents what is actually completed. This is becoming new and commonplace. You know, before it was, you know, this is the permit set of drawings, and then you construct, and then you're done. Very rarely would someone go back and say, okay, now let us compare what we have created to what we finished during the construction documentation phase. To a certain degree, they're updated, but never a full post-construction survey has been done generally, and that's become a part of the process. And then as smart, I guess, processes have been integrated into construction, we're starting to see these models being used for, like I said, virtual building maps, so you can see where you are and how you get around a larger building. For facilities management, essentially tracking equipment and their life cycle and when things need to be replaced, et cetera, et cetera. Marketing for purposes of virtual reality, augmented reality, that can also happen during the pre-construction phase as well. And video games, some, you know, buildings, they're built, you know, for the purpose of construction. Some can be built entirely for digital purposes, and you know, video games is one of those purposes. Now, what is reality capture? Getting to the point. Reality capture is the process of creating a 3D model based on photographs or laser scanning. Laser scanning being the most popular route today. Most reality capture hardware outputs photographs, a model mesh, or a cloud of points, also known as a point cloud, to be used to create a 3D model. Each of these are captured scene by scene, scan by scan. The number of scenes or scans and time of capture depends on the hardware used, site conditions, and scope of what is to be captured. So that's pretty much self-explanatory. Depending on your hardware, that's going to determine, speed, quality, and range of capture for any given time. And then obviously your scope is going to determine what you need to capture, and that may cause you to have to scan more or less depending on the conditions. The photographs, meshes, and or point clouds after being captured are processed in a software that can handle these specific file formats so that each individual captured scene can be stitched together with others to create a complete seamless project. So obviously after you complete all of your laser scanning processes or reality capture, you then have to bring that into a software where you stitch each of those scans together. You're going to get one complete model, or you can break it down into separate models depending on the size and scope of your project. Some people might break it up into floors. You might break it up into phases, just sort of depends. If it's a small enough project, it might just be one complete file. But that's typically the process. You do the scanning in the field, then you process all of that on a third-party software that's usually related to the device. And then finally, that file is going to be imported into a compatible BIM software of choice to be used in creating a 3D model. And for most of us, obviously, that's Revit. So, doing the laser scan, processing it in Autodesk Recap or like a Cyclone or something similar, and then importing that point cloud into Revit or another 3D modeling tool to actually use to do your modeling. And this is just a graphic sort of showing the process. The device in this picture is actually a BLK360, which is a good entry-level laser scanner that I actually used to use like a few years ago before I upgraded. How does reality capture apply to as-built? The reality capture process can provide site data as accurately as 1/32 inches or 1.9 millimeters. Now, depending on the scope of your project, this may be more accurate than necessary, but no one's ever going to complain about more accurate data. And typically, this is what you can get from the best scanners out there. And it obviously far exceeds the accuracy from measuring tape or laser measuring devices. When you're using measuring tape, you're definitely not marking things down to the 32nd. And if you are, because it's a measuring tape, you're getting as close as you can. Who knows if the other guy that's in the electrical trade is doing the same, or the mechanical guy, et cetera, et cetera. Laser measuring devices will obviously get you a little bit more consistent accuracy. But when you start measuring curves or angled walls and things of that nature that you may not be able to perceive with the human eye, then your accuracy obviously gets a little bit warped. Reality capture provides current and actual data all at once. This eliminates the concern that as-built drawings may not necessarily reflect actual site conditions and the need to conduct a site visit to verify such suspicions. So as I was saying, even if you're given a set of drawings, you don't really know if the information that you're given is correct. So oftentimes, you'll still have to go back out into the site and verify what's there anyway. So taking the time to track down these drawings, start a design based off of those drawings, and then have to go on site to verify the data, which is usually incorrect, and then go back and fix all of the information based on what you found out in the field is just a tedious process. And to eliminate all those steps, you just go to the site one time, use this reality capture device, get the information accurately, and then you don't have to worry about it anymore. The 3D model created from the reality capture process can then be used to create drawing sheets or 3D models for whatever purpose is necessary. So obviously BIM is more than 3D modeling. It can be estimation, there's 4D, 5D, 6D, and even I think 7D BIM at this point. But reality capture is ultimately just giving you what is on the site at any given time. That information can be used however you want. But it's obviously at its infancy a foundation for creating a 3D model. And 3D models in Revit are used to create sheets. Sheets are used for construction. So, you know, it's pretty obvious how it is a part of the as-built process and the BIM process and the construction process as a whole. In short, the output of reality capture is an as-built. Like I said, as-built is showing you, an as-built is a drawing that's going to show you what is on site currently. The output of reality capture, the output of a laser scan is going to be a cloud of points, which is essentially showing you what is currently on site. Even without modeling, you will know what's on site, but obviously you need to actually create that 3D model so that you have elements to use for coordination, et cetera, et cetera. What is a point cloud? A point cloud is a file that consists of a large group or cloud of points that represents a space and is used to create a 3D model. It is created from capturing data from a laser scanner or comparable reality capture device. The output of reality capture is usually a point cloud. If you use a Matterport or something like that, you might get a mesh. There are 360-degree cameras that you can use for reality capture purposes, not just for the camera functionality. I have a Ryko Theta camera that can be used for that exact purpose, and it'll give you a mesh as well, as opposed to a cloud of points. But you also have the option for a point cloud as well. Point clouds are usually assembled in a photogrammetry software, which is the third-party software that is used to process the data from a laser scan. And then after that, that data is always imported into Revit or something, as discussed earlier, that can be used for the 3D modeling purposes. This image is showing an example of a point cloud. Depending on the software or hardware that you're using, you can sort of toggle on and off the view state. So all of these are essentially point clouds. The first is just showing the infrared sort of heat map view of a point cloud. The second one is just showing the colored point cloud as is, how it would normally show up. And then the third image all the way to the right is showing that point cloud with photographs overlaid, usually a laser scanner. Once it'll do one rotation to gather the point cloud data, and then it will essentially take a series of pictures while rotating around that space in order to, I guess, supplement that point cloud data. So you can usually view the point cloud on its own, and then you can usually use the point cloud with the images that were taken in that same capture at the same time. Now you have the option of turning that off, but it's usually very helpful in the modeling process, so I keep it on. But it does extend the time that it takes to capture your data out in the field. I mean, looking at it now, it almost looks like a complete model, even before you've modeled it. How can you tell the difference between good and bad data? More points equals more data. Thicker points equals more noise equals cheaper laser scanners. So as you saw in the previous image, there's they look like really tiny dots that are coming together to make this point cloud. Cheaper lasers will typically have larger, thicker dots, which decreases the accuracy because it's harder to find sort of the center of those dots and how they relate to each other, especially when there are a lot of them grouped in one place. So it could cause a lot of inaccuracies in the modeling process. Obviously, more points equals more data, because that means you're going to have more points tightly packed together, and it's easier to see the association between elements. Whereas if you had fewer points spaced further apart, now there's a lot more guesstimation as far as how each of these points connect to each other when you're creating your model. Now, typically, you know, due to the accuracy necessary, that's not going to be that big of a deal, but there may come a time if you're modeling equipment or utilities, MEP, things of that nature, where it really does play a part. Walls, not so much. For reality capture that involves photo stitching, site conditions such as light and camera quality affect the ease of determining elements from each other. I mean, that's pretty self-explanatory. Like a camera taking a photo in low light is going to give you a lower quality picture than taking one in, better lighting conditions. And the same is for, a Matterport or other reality capture devices that rely on photogrammetry and cameras for the bulk of their work. For reality capture that involves laser scanners, weather affects the quality of output. Conditions such as rain can add much noise to a final output. Laser scanners, they work by shooting out a laser. Whatever that laser hits, it bounces back. And then that's how you sort of get the depth information, and you're able to sort of create this cloud of points. So imagine being outside trying to do this during the rain. You shoot out a laser, the laser is picking up on all the little rain droplets, and now you can't really discern the building that you were trying to scan from it raining outside, which is typically why it's always said that laser scanners are not usable, out in inclement weather. And aside from that, I think someone needs to be muted. Okay, sorry about that. So obviously that's why it's said that most laser scanners should not be used in inclement weather. Aside from that, obviously you don't want to put very expensive equipment out in the rain, as with any electronics. So I think that goes without saying. And obviously, finally, the more realistic the output, the better data. So the more points, the more smooth your output is going to look. And then obviously the smoother your output, the better the data. The more blocky your output looks, usually the worse the data. The same for, pictures. The more granulated and pixelated in images, the worse the picture quality is. And the smoother the picture, the better the quality is. So it's all the same thinking and logic for laser scanning and reality capture. And this is just a small example of, I guess, good versus bad data. This picture is actually terrible, but just to get the point across, I think the left image and the right image is showing the actual registration process of a point cloud. So oftentimes there will be some automatic registration that can be done within the hardware. Sometimes it does not get it right. As you can see on the left side, it's the red and the green wall. That is essentially the same wall being picked up in two different scans, and it has it offset by, however far in the left image, and then the right image is obviously showing proper registration where both scans, the wall being picked up in both scans is in the same place. So you know that the information is accurate. Now, what are the pros and cons of reality capture? The pros obviously is more accurate data, as we've talked about time and time again. There's quicker data capture. Obviously, just putting a laser scanner in a room and pressing a button and let it spin around is a lot easier than going around that room with measuring tape, having multiple people trying to pick up dimensions. There's a potential lower overall construction cost. Obviously, the overhead for an actual reality capture device is pretty expensive, but over the lifetime of using that hardware, you're going to save yourself a lot of money in construction costs due to reduced RFIs and change orders and things of that nature. So it's like pay a lot more upfront and then save a lot down the line. And I mean, typically these things pay for themselves depending on the amount of work you have in as little as, 6 months. But typically like 2 to 3 years. And then you're just making money from there. No more assuming. Like I said, multiple trades have multiple site surveyors that all make their own assumptions when they're out in the field doing measuring. If you have existing as-builts, you might make the assumption that they're correct with what is on site if you haven't seen it. So just take out the assuming, go to the site, use the laser scanner, get the information right the first time. You don't have to worry about assumptions because you've seen it and this reality capture device has picked up that information. No more secondary verification of site conditions. Like you said, if you get as-built drawings and you don't quite believe them and you want to go on site anyway, then it's like you've wasted a lot of time doing drawings based on those existing condition drawings that you received, only to go back out in the field anyway and verify things by hand, or later on by reality capture when you figure out that that's the best tool for the job. So just skip doing multiple steps. Just do it all right the first time, obviously. Eliminates having to track down old historical as-builts. As I mentioned previously, sometimes there aren't drawings, or someone won't provide drawings, or the drawings are hard to find. And what's the point in waiting weeks for trying to track all that down when in one day you can pretty much get all the information that you need? Cons: equipment overhead. Like I said, it is a very expensive upfront cost, but it definitely pays for itself over time and quickly. Less portable than manual tools. Obviously, carrying a tape measure or a laser measuring device, you can stick it in your pocket, stick it in your bag. These things have their own backpacks. I wouldn't say that they're very heavy, but it's noticeable weight if you're carrying around a laser scanner and a tripod and all this extra equipment. But typically that's not a big deal. You throw it in your car or put it in a backpack, whatever you have to do, and get over it. Regardless, you have to carry something. I guess having a little bit of extra weight isn't always that terrible. Next. So what are the current tools used for reality capture? So here I have pictured a 360 camera, the Ryko Theta that I mentioned earlier. You can use that both for gathering point cloud data. You can use it for walkthroughs. I mainly use it for 360 photos to supplement my laser scanning. So I just like to show what is on site in picture form, as well as the point cloud that I get from the laser scan. Now you can obviously use your phone or any other camera to take flat pictures, but as we all know, there's always that picture that we miss. So I like to use a 360 camera because it'll capture everything, the full 360, up, down, left, right, whichever direction, all in one picture, and then you can just look and rotate around. Laser scanners, Matterports are used for a lot of walkthroughs. For real estate, people use it for laser scanning purposes. It's not the ideal tool to use, but it does work. The accuracy has gotten better. The speed has also gotten better. And then obviously there are all the other tools and accessories that you have to use with these devices. You put them on drones, you have tripods. Most of them you have to use an app to operate, and the apps are generally have to be used with an iPad only, not Android devices. Now it's getting to the point, if you have a newer iPhone, it'll work with that. But typically, I don't know why, but everything is built for iPad. Depending on the device, it might have replaceable batteries or rechargeable batteries. So, batteries will become your life. You're going to have battery packs. You're going to have a lot of flash drives to have all of your data, and memory sticks and things of that nature. If you're using camera equipment along with this to get, site pictures, obviously like gimbals for stabilization. Laser level is one thing. Some reality capture laser scanners, they have built-in GIS and VIS sensors, so you're able to track leveling and location relative to a previous scan. Others do not have that capability, in which case you usually use a laser level to sort of set up a line of sight, and then you just tape paper targets like all over your construction site, and they're usually numbered. And with that, you're able to just keep track of where you are in the construction site. That way, when you go and stitch all of these scans together later, you can say, okay, there is target number 1. So target number 1 in scan number 1 needs to align with target number 1 in scan number 12. So it just kind of has that visual placeholder so that you know where things are when you're back on your computer processing all this stuff together. And then obviously all the apps and software that you have to use to process laser scanners, to do your 3D modeling, Revit, et cetera, et cetera. We don't really need to go into that. Now, what do you need to know to compare one tool to another when you finally decide to get into the reality capture space? Accuracy is obviously the main thing. Depending on the scope of your project, you might have different accuracy requirements, but typically most stationary laser scanners that are on tripods are can give you accuracy up to 1/32 of an inch, or 1.9 millimeters is usually what it will say. Typically, different companies may more or less fudge the numbers. It may not be as accurate as they say they are, but at least the higher the accuracy that they show relative to other companies, you know that, like, okay, if this says it's 1/32 and the other one says it's 1/4, those numbers may not be accurate, but you know at least that the one that says 1/32 is more than likely more accurate than the other. And then there are people that go on YouTube and do product testing and stuff, so they usually dive down into what the truth of these numbers are. But all in all, the accuracy is obviously the most important thing. Capture distance, along with accuracy, it's how accurate can you be and up to what range. How close or far does your device have to be from the subject to pick it up and to scan it? And what's required is obviously depends on what your scope is. If you have to get a lot of small details, you might want a smaller scanner that can squeeze behind certain equipment so that you can capture that data. If that's not so important, maybe the closest range is not important, but you want to see how far you can shoot your laser scanner, or how far you can capture. Battery life is an important one, because depending on the size of your project, oftentimes your battery is going to die. So do you have to carry an external battery pack to charge as you go? Do you need to buy extra batteries so that when the ones in there die, you can just swap them out, charge them, put fresh ones in there, and then keep going, and not have to wait half a day for everything to charge and then start back up again? Megapixels and camera sensor size for things like 360 cameras, things like the Matterport. Obviously, the better the sensor, the more megapixels, the smoother the quality, and the more accurate and better the reality capture device is going to be. Outputs, how versatile is your hardware? And that all of that is very important based on the variance of your output. So typically, you're going to get a cloud of points now. Even the hardware that outputs a mesh generally will output a cloud of points. I think it's just become the industry of standard now. So you just have to make sure that the output from your hardware matches up with something that you can use based on what you're using to do your 3D modeling. So, if you're using Revit and your hardware doesn't output a format that can be used in Revit, then you might want to consider other hardware. Finally, accessories. What else is needed to get your final output? Additional hardware, software, apps, devices. Do you need a tripod? Do you need extra batteries, memory sticks? Usually it's all branded accessories with the exception of tripods. So, that upfront cost of just the device may not accurately represent, your bottom line cost. You might have something for $30,000 and then you have to get $50,000 worth of accessories to do what you need to do. Or you might just have something that's $40,000 and with that, it's has everything you need, and it's ultimately cheaper than, technically a cheaper laser scanner because it doesn't require as many accessories. So, just do your research. Obviously, this day and age, there are always product reviews and stuff. So you can try before you buy with a lot of things. So just figure out typically what you have to do, what you need, look up these product reviews before you make your purchases. And so you ultimately don't regret what you end up buying. Who are the major players in the reality capture space? So Matterport is at the top, used for photogrammetry. So they don't necessarily output a cloud of points, but a mesh. They are basically industry standard for real estate. They sort of give you a Google Maps looking output as far as like walkthroughs and things like that. It also does give you a point cloud. The accuracy is not as good as using a laser scanner, but typically for a lot of trades, it's good enough. And because the cost is exponentially lower than a laser scanner, most people just forego accuracy for the cost. They use a Matterport and just go on with their days. Other than that, when you get into laser scanners, it's Leica, Faro, and Trimble. Those are the top 3 names in the laser scanning space. I use Leica personally, but other people will give you reasons why they like Faro or Trimble, mainly because they work for the companies, but also there just might be features that you like better. It might be aesthetically more pleasing. The software that you use to do all the processing might be easier for you depending on what you're used to. So, you know, I would just take a look at that. Like I said, depending on the scope, the accuracy, the personal needs that you have or professional needs that you have, you know, you can't go wrong with any of these companies. But yeah, typically these are the top 3 players. In the 360 photography space, Ryko seems to be the winner. I use 360 cameras, like I said, to supplement my laser scans. The laser scan gives you a nice cloud of points, but every now and then there might be details you can't pick up, and it's better seen in a camera. And like I said, myself, rather than taking a million normal photographs, I just take 360 photographs in the same place that I do my laser scans. So that way I have a laser scan, it picks up the cloud of points. I have a 360 photo in the same place. It'll give me a picture of everything in that space all at that time. And then it can be used with Matterport to make the same walkthroughs and for a lot cheaper price than a Matterport. So most people don't know that, but you can even forego a Matterport for a Ryko 360 camera to do all of the same sort of walkthrough work. Now, when you get into the point clouds, the Matterport is going to be better because it has a better camera. But, you know, like I said, depending on your use case, a lot of these hardware are interchangeable. And then finally, honorable mentions, Paracosm, Dot Products, and EIN Scan. They're relatively newer to the market. They're trying to gain, I guess, a lot of favor by having cheaper equipment, more accessible equipment for people to use, relatively compared to like the accuracy of the big players. They're not quite there yet. Obviously, there's support issues and all these other things that go along with having a smaller company, but I have no doubt that, you know, everyone will get better eventually, and, you know, maybe they'll overtake one of these big players one day. But these are the names definitely to consider if you're trying to get into the reality capture space, or if you're already in there and you just needed to know like what the differences were or what else is out there in terms of comparison. How does reality capture compare to traditional methods of surveying? We don't really have to talk about this too much because we already have. You know, you have multiple people, multiple trades using manual tools. And their accuracy all depends on the person, what they feel is accurate, you know, what they think they see on the measuring tape, et cetera, et cetera. Obviously, with using a reality capture device, there's one single source of truth and it captures everything. So whether I want to capture the MEP or not, if I'm in that space and the MEP is visible, I'm going to pick it up. And the accuracy that I get with my laser scan is going to be the same. For the walls, it'll be the same for the MEP, and it's all coming from this one device. It's not multiple people making assumptions and doing their own measuring. And then obviously when you get into more complicated construction, when you think a wall or a room is square and it's not, and it's converging one way or another, or if you think a wall is flat and the wall is wavy or curvy, or if you have an actual curved wall. I don't know how many people have tried to measure a curved wall and then translate that into a 3D model, but it's a very difficult process involving a whole bunch of other tools other than measuring tape. So like using a laser scanner just saves a lot of headache in capturing all of that, because it's just bouncing off of the walls, bouncing off of the utilities, and you're just getting accurate data without having to do all of this other you know, complicated math to figure out curves of walls and whether this wall is flat and whether this room is square. Just save a lot of time. And when you're saving time, you're obviously saving money. And what saves time and what makes money makes everybody happy and opens up opportunity for more work and more money. How do current reality capture tools compare to traditional processes? And this is basically what I just talked about. You know, you have one single source of truth versus multiple people doing the same job, and you ultimately get more accurate data. And if anything were to be incorrect, not that it usually ever is, everything is correct with respect to one variable as opposed to, you know, many variables such as people, tool used, you know, how accurate they measured, et cetera, et cetera. What are reality capture best practices? So this is in an ideal world. In a vacuum, it's not always the case or not always an option, but typically this is what I would see as the best practices for reality capture using the laser scanner or photogrammetry like Matterport device. Number one, you want to figure out the constraints of your hardware and map out your capture points beforehand based on those limitations. So ideally, if you're given a set of existing plans, even if you're not going to use them to model, it's a great tool to at least see the space before you get on site and say, okay, I need to scan here, 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 and here. So before I get there, and you know, I can eliminate having to go on site and essentially do a walkthrough beforehand to see where everything is. I can map it out on these drawings. But with that being said, drawings are oftentimes wrong. So you can go through all of that work and it still can be time wasted because you get out onto the site and it looks nothing like the drawings you were given. But in an ideal world, it'll be close, and this will be a helpful part of the process. If your hardware does not have GIS or VIS mapping, place targets to know your place during point cloud registration. I talked about targets before. Obviously, you throw up a laser level so you can have a line of sight. You put paper targets on the wall. It literally looks like a bullseye. That way, as you do each scan, you pick up these targets. You can see they're usually numbered 1 through however many you have. So if you're on scan 1 and you're on scan 56 and they essentially go into the same room at some point, you'll say, okay, I picked up target number 1 in both of these scans. I know that that needs to be aligned. You know, so you can sort of get your bearings when you're not on site anymore in case you don't remember what a particular space looks like. You typically want to scan every corner of every room. You want to scan both inside, outside, and in between all doorways. That helps connecting rooms to other rooms. This is especially helpful when you have long corridors, when the rooms look exactly the same, especially during early construction or if a place has been gutted and there really isn't any visual cues as to the differences between one room or another. Taking all these scans, connecting all these points is going to be the best thing for you as far as being able to process all that information later on. Have your site as clear of obstacles as possible. The more obstacles in your way as you're scanning, that's the more things that you have to walk over, the more scans that you have to do. If things can be pushed aside, moved out, put into a corner, that's a lot easier than having to scan around them. You know, if you want to see the corner of a wall, it's so much easier to just be able to scan that corner than to have to scan around a bunch of junk that's in the way just because you're trying to capture the details of a room that otherwise would be very easy to capture. Provide numerous 360-degree photos to supplement the laser scan. Like I said, I always provide photos with my laser scans just so that I can pick up on elements in case that they are not legible from the point cloud. That's not usually necessary, But most companies will ask you to provide some sort of photographs anyway when you do a survey. So this just sort of satisfies that requirement regardless. Scan in color if possible. Obviously, color, point cloud versus a black and white is just going to give you more detail, just like a color photo is going to give you a little bit more detail than a black and white photo. It helps you pick out elements a lot easier. Make sure your hardware is able to output data that matches your scope requirements. Like I said, if the output can't be used on the software that you're using, then it's pointless. Scan your site when empty or inactive if possible. People being in the way when you scan can oftentimes mess up a scan. A laser scanner like the one that I have, it'll try and eliminate people by doing a scan twice. But that obviously takes more time. So to save time, save headache, just like you want to remove obstacles when you scan, getting other people out of the way is obviously helpful when possible. Sometimes it's not, and you have to deal with it, but if you can help it, that's one thing I would try to do. Avoid capture in bad weather conditions. I already talked about laser scanning in the rain or inclement weather. You don't want to mess up that expensive equipment, and you also don't want to pick up a lot of that noise from, the laser scanner bouncing off of rain droplets, etc. And then when it comes to things like a Matterport, obviously you want good lighting conditions, etc., so that way you get better quality photos and better data. Finally, consider your scope. Often open spaces can be technically captured in a few scans, but if ceiling data is important, you may require more to get on both sides of a beam or to capture lighting, MEP information, etc. I've seen this a million times. Someone has to do a site survey of a warehouse. It's a wide open warehouse. They're saying this laser scanner can capture up to 100 feet. They do every corner of the warehouse, which is probably like 4 scans. They'll do inside, outside, in between the door. That'll be 7 scans, and they'll call it a day. Technically, they captured the walls, the floors, and the columns of this whole site. Now, if I had beams in the ceiling that were exposed, lighting, MEP information, by trying to maximize the extent of their capture and minimize scans, they could have missed out on a lot of ceiling data there. So just know your scope when you're going to do a laser scan. If ceiling data is important, even if you can scan, 100 feet away, from each scan, are you going to capture everything in the ceiling while doing that? Think about the perspective, think about your scope. What is the current ideal reality capture process? And this kind of ties into the previous slide. Number one, you want to lay out your scan locations ahead of time, if possible. Number two, use a laser level to place targets throughout the space so that you can use that in your post-processing. But obviously that's not necessary if you have a newer laser scanner that has GIS or VIS, some sort of auto registration built in. Cover all reflective surfaces to avoid confusion of duplicate and mirrored data. This is a big thing, especially with laser scanners. Lasers do not like mirrors. So if you're in a room, I've had to do a hall of mirrors before, and basically the information that you get is very difficult to interpret, because not only are you capturing a wall with a mirror on it, but it's perceiving the reflection in the mirror as an actual space as well. So sometimes you will get a mirror image of the space that you're in because of the reflection in a mirror. So, if you can take the time to find all mirrors and sort of cover them up with wax paper or something like that, so that, you can prevent as much of this reflectivity as possible, that's also always great. Like I said, capture all corners of a room, capture inside, outside, and in between all entrances. It's just better for linking all the scans later. Accurately distance scans to capture all information in the scope. Going back to the warehouse example, be mindful of your scope. Don't think of just the walls and the floors. Think about potentially the ceiling information as well. Or if you have to get mechanical equipment, do I need to get all the way around so I can capture all the details of this equipment? The higher the detail, the more scans usually necessary. If you're doing a mechanical room, like the example I was about to give, Mechanical rooms usually have a lot of very detailed equipment. You can probably get a mechanical room scan pretty easily, but if you need to get the details of that equipment, you typically need to spend a lot of time going around each of those pieces of equipment to make sure that all of the data is picked up. And usually when you're laser scanning, you're using it along your laser scanner with an app. So as you're capturing the data, you will be able to see in real time what you captured. So it's not like you're guessing or hoping that you got the information. You're usually able to see it. So you'll be able to look on your iPad, say, I don't think I got that area quite as well as I wanted to. Let me take another scan. Capture 360 photographs in all scan locations. Like I said, I use it to supplement my my laser scan and also to satisfy my photo requirements, usually when I'm doing a site survey, but 360 photographs have been a lifesaver a million times. It takes no time to do, and it saves you a ton of time or going back to the site if something is missed. Create a photo key plan for your 360 photographs. Obviously, just taking pictures is helpful, but to make it more helpful, if you can map all those pictures on a plan so people know where they are in the space, it's usually a lot more easy to ingest and easy to use that data. Use photogrammetry software to process and register point clouds. So obviously after you get all of your scans, you have to import it into your computer. You're going to use Cyclone with Leica. You're going to use Autodesk Recap, something like that to put all of your scans together to create a file that you're eventually going to model from. And like I said earlier, if it's a smaller project, it might be one file that you output. If it's a larger project, depending on the scope, the number of phases, or whether you want to do it by floor, you might want to separate that scan up. That way you have smaller files to work with. When you're in Revit, you can put things on different work sets or turn it on and off different scans as opposed to turning on and off the full scan. And definitely when it comes to your laptop or computer capabilities, having the ability to do that is going to save you a lot of hassle. It's going to save you a lot of lag and a lot of basically clunky movement around when you're trying to do modeling. And finally, use the final point cloud and 360 photographs to create a 3D model, which is ultimately what you want to do. You want to create that 3D model so you can have those construction documents so that you can go out and construct whatever it is that you're trying to build. Where else in the construction process has reality capture been used? Already talked about that. Pre-construction, it's used for the DD and CD phases. During construction, you can use it to provide progress updates or current models to help with coordination. Post-construction, it can be used for record keeping, facilities management, and smart building applications such as, a virtual map showing where you are. Sometimes there are visual apps for turning on and off lights, et cetera, and they might integrate that with the 3D model. So you can just go to a room, click on the lights, and they'll turn on and off. There are a lot of cool things out there right now. And everyone just, integrates that model just to make it a lot cooler looking when you use it. What are the other use cases for reality capture devices? Live streaming, prototyping, creating renderings, experiences for marketing purposes, walkthroughs for real estate listings, drive-bys for Google Maps, models for video games. Possibilities are endless, obviously. You're using a tool that's allowing you to create a model, that's allowing you to create a walkthrough. So anything that any use case that you can think of for a 3D model or a walkthrough, or a camera for that matter, the possibilities are pretty much endless. We're in the construction industry, so obviously there are uses there, but if you personally own one of these things, like you can get a lot of value out of it and use these for a lot of different use cases. The return on investment obviously is complete confidence in your as-built, no more guessing. Versatile data output, you're not just doing hand measurements on a 2D set of flat plans or a sketch that you created. You're given the resources to create a 3D model, whether you want to or not, and that 3D model can be used to create your drawing sheets. Clear and concise data, not illegible handwriting that you have to digitize and read someone else's handwriting or whatever the case may be. everything is clear, concise, digital, and ready to use. Obviously, the return on investment is time saved in the scanning process, which allows for more projects and profit. Capture data for all trades at once, so there's like one single source of truth, which we already talked about. Smoother construction due to less RFIs. Obviously, the better the data you're starting with, the less guesswork and the less unforeseen circumstances in the field. And then, as I discussed earlier, the hardware overhead pays for itself. The future holds greater accuracy. Obviously, accuracy can improve. Faster data capture. Things are always going to get harder, better, faster, stronger. Automation of point cloud to 3D model. There are companies that are working on this, so they're trying to eliminate that process of even turning a point cloud into a 3D model by automating it and seeing elements. Not quite there yet, but getting closer. Robot-driven hardware. Instead of picking up a tripod and moving it, being able to roll around in a rover or something, and just controlling it by remote control. That's obviously a consideration for the future. Better cameras, better lasers. Finally, X-ray capabilities is a big one that people are looking for. There's a lot of work that it takes to look above a ceiling or below a floor, so being able to look through them would be very, very ideal. Not quite possible yet, or maybe too expensive perhaps, but in any case, it would be a great consideration for the future. What is missing currently? Automation, which is obviously in progress right now. Self-propelled laser scanners. So, aside from having a remote control rover, something that you can just map out a scene for yourself and it'll just move around by itself and you don't have to worry about it. Well, I guess the only thing you'd have to worry about is people knocking over your device and ruining your expensive equipment. Equal accuracy is cross SLAM and stationary laser scanners. So I basically talked about stationary laser scanners, but there are also SLAM scanners that you can hold in your hand and basically walk around, and it's in comparison, like a SLAM scanner to a stationary scanner is like a camcorder to a camera. So it's one continuous capture versus putting a scanner on a tripod and taking individual scans. The only downside to that is the battery life right now for SLAM scanners, and then the accuracy doesn't quite measure up to stationary scanners. If you have a small interior project and the accuracy is not as important, SLAM scanners will be great. Otherwise, I would say use a stationary scanner, but the prices are pretty much the same, so they're typically not used. And then obviously automatic processing of everything. People want to just be able to scan and then end up with a 3D model. No one wants to do the post-processing, et cetera, et cetera. So obviously automating that process is ideal for the future. And that's pretty much my presentation. So at this point, I'd say thank you for hanging in there and listening. And I want to take some time to take a few questions. I was told we have like maybe 10 minutes or so. So are there any questions?
Okay, thank you for the special presentation.
I'm hearing
so one learned a lot during the 1 hour presentation. So if anyone have a question, kindly indicate by raising your hand, or you can also type the question in the chat box. I'm sure we'll have maybe about 10 minutes of the scene to answer the question, to go through the question. But before then, I think there was someone asked a question when you are going through the presentation. Let me look for that again. The question is from Victor. Okay, she asks, how is the software able to interpret the 360 photos? In my experience, the software tends to reject them. So she's asking how the software interprets 360 photos.
All right, so I see something in the group chat. It says, how is the software able to interpret 360 photos? In my experience, the software tends to reject them. So that's a good question. So usually I am not using the 360 photos or trying to import them into the actual software, because the point cloud creates a good enough image that you're going to use in Revit for modeling purposes. But let's say I'm in a corner designing a certain area and I can't quite get what that element is. I'll go into like my photo key planner, I'll go into my 360 photos as an aside, just to view the photo and see what's there. That way I can use that to help myself model. So I'm not necessarily importing the photos. I'm more or less just using them as a reference as I would any other photo, because ultimately your point cloud is giving you the information that you need to model, but you may just not know, okay, where is the separation of one element versus another, or something of that matter. I see another question. Is there any application that can automatically generate elements from point cloud rather than creating the elements individually? There are applications. They're mostly for MEP. I would say the best tools right now for some sort of point cloud to element creation, they're mainly in the space of like structural and plumbing or mechanical piping. It's obviously pretty easy to pick up a radius and sort of create a pipe. Once you do that, you're still going to have to deal with trying to figure out the connections and double checking. There are companies that claim that they do it. I actually have done work for one of these said companies. I guess it's not great to mention their name because they are still selling themselves as doing automation. I mean, ultimately, construction lacks a lot of, IT and great coders. And I think we're getting to the point where we're trying to get great developers to make these tools for us. And until that happens, we're going to have these bottlenecks where, companies are trying to get this service going. They're trying to get crowdfunding in order to make this stuff happen. No one is really there yet. And the few tools that do work, honestly, you'll spend so much time trying to clean up what they give you that you're just better off doing it yourself. I mean, creating pipe and duct work is a pretty simple process to begin with when you're talking about straight pipes and stuff like that. So I would save your money and just do it yourself instead of trying to automate it, at least for now.
Okay, thank you for the answer, Mr. Joseph. Using his time. So, Mr. Joseph, kindly unmute your mic and ask your question.
I'm
okay,
sorry?
I want to appreciate the presenter for this wonderful presentation. Though I joined very, very late, I was looking forward for something like this. Because as an individual, we have a challenge relating using a recap.
Okay.
To assess a plant, an existing plant that they don't have working drawings for that plant.
Okay.
And what the client needs is for us to use to generate that plant. So
okay.
We contacted Autodesk and they gave us an option of recap. So,
okay.
But the challenge we have, we don't want a situation whereby if we use reality capture, we will now still go into a situation of tracing. Is there any way that the image, after you capture the image, is there any way that it can automatically generate a 3D sensitive, like your piping, all those your piping, your valve will be in 3D to ease the stress of tracing those things yourself?
Yeah, so like I said, it kind of ties into the last question. There are a few companies and a few like plugins that claim to do that. The plugins that I have had the pleasure of using, it's not really that accurate. And then you end up having to go back and do the cleanup anyway. The radius might be off, or you have to go back and add the accurate connections that you need for pipes, all those connections and stuff like that. And obviously when you're coordinating MEP, especially when you're talking about mechanical stuff, you know, inches, you know, and fractions of inches matter. So to be off and having to go back and double check that is not usually helpful. And like I said, there are companies that will do it for you. They claim that it's automated. It is typically not automated. Like I said, I've worked with like 2 or 3 companies that sell services saying that they automate it. When in reality, they just have someone in the background like me, you, or anybody else who uses Revit. They just have them creating the model. So, I mean, if you don't want to create the model yourself, there are obviously people that will do it for you, but there is no software that is 100% going to take that data and automatically create a model for you. Like I think that's where everyone is trying to go, but we're just not quite there yet.
Okay, I think I will appreciate, as a body, professional body, which we are, let's throw this back to Autodesk, that this is the challenge we are having, because they embrace feedback from end user. We send this feedback to Autodesk, that is there any possibility they can give us they can add to that recap so that it will be 3D intelligence, so that we'll pass through we'll end the phase of retracing what we have done. I think it will be a better workflow for us.
I agree. But what I will say to that is that because Autodesk doesn't make any hardware, that's going to be a difficult battle. These laser scanning devices made by, you know, Leica, Faro, et cetera, they are using their own software to process. So I was using Recap in the beginning. I didn't really like it too much, but it was all that I had to use. But now that I have a Leica scanner, I use Leica software, which is Cyclone, to process everything. So I guess ultimately what I'm trying to say is that most of these guys have their own software for their laser scanners. So Autodesk really doesn't have any reason, and they haven't really supported updating Recap in the past few years, period. But they don't really have any reason to add features because they know that people are just not using that software, and they're using the software for the scanner, you know, that it's made for, especially now because the software is being bundled with the hardware. So it's making it even easier for end users to say, okay, I'm going to use this software because it's already bundled with my hardware, instead of having to additionally pay for Recap when it does the same thing as this software I already have. But I 100% agree with you.
It's okay. Thank you.
You're welcome.
This is Abdul. I want to ask one question.
Sure.
So you mentioned earlier one of your slides, something like as built and in a design phase. So can you give us more details on how you can use as built on the design phase of a project?
Sure. So, I mean, typically a lot of the work that I do is for like tenant improvement. So it'll be going into an existing building and obviously doing some sort of renovation. And this whole process has sort of revolutionized, you know, that, because you're using this laser scan to sort of create a 3D model. And with that, you're getting what's currently there. You know, they say, we want to renovate this space. And here is what we want to do, or we have a design for this space, but we need to know what is there in order to make sure our design works. So we're going to take this laser scanner, go out to the site. It's going to capture the site as is, so we know what is there right now. That way, when we start building, you know, or when we start designing in Revit our design, we know that we have a good foundation. As opposed to prior, everyone would have to go out and use, you know, go out to a site and use measuring tape to figure out what the dimensions of things were. Or they would just be given a set of like CAD files, and they would say, this is the site, make your designs based off of that. And people would do that, and they would start building, and then they would go out on site and realize this isn't what this building looks like right now. So it's just a way of doing your due diligence, but doing it a lot faster. That way, you get accurate as-built information that you can use for your design process.
Thank you.
You're welcome. Are there any more questions?
Okay, I think there's no more question.
All right.
So thank you once again, Mr. Christopher, for making out your time despite the condition we find ourselves in global at the moment.
Thank you guys. I hope you all learned something today and you're staying safe out there. Thank you very much.
Thank you very much for making the time to lecture us today. We hope to have you again anytime soon in our subsequent webinars on BIM topics.
Thanks. And if anybody has any questions, feel free to reach out as well. I'm sure my contact information will be somewhere for any questions after the fact.
Okay, maybe you could type in your email address maybe in the chat box if any other person wants to reach you personally. If we always do that.
Thank you.
Yes, the recording will be made available. This is being recorded and hopefully before the end of tomorrow, it will be available on the YouTube channel, the recorded version of the BIM talk. So if you missed any part of it, you can always watch it again on your own convenience.
All right.
So thanks everyone for making up time to tune into our webinar today. We hope to see you in subsequent ones. And also